So now that we know how to count the number of significant digits within a number, the next thing we want to do is figure out how we can use the number of significant digits we determine in calculations. And these calculations really boil down to two separate groups. The first group involves addition and subtraction, and our second group involves multiplication and division. So in group number one, whenever we're dealing with mathematical operations that involve addition or subtraction, the number of significant digits is determined by the total number of decimal places in the individual numbers. So in addition subtraction, the number of decimal places becomes really important. Whereas with multiplication division, the only thing that really matters is the total number of significant digits. Okay, so let's look at an example here. So if we have 2.002 plus 3.68. Okay, so if you put this into your calculator, what you're going to see is that this answer ends up being 5.682. Right, so the question though is how many significant digits should this answer have? And the answer to that question lies in the number of digits in the decimal places. So in this first number we see 1, 2, 3 decimal places, and in the second number we only see 2. So we have out to the hundredths. What this means is that our answer needs to have 2 decimal places. So I have 1 decimal place, 2 decimal places, so this 2 is not significant. So our answer is 5.68. Okay? That's how you do it every time you have an addition or a subtraction. With a multiplication or division, we actually need to count the number of significant digits. And the smallest number of significant digits is the number that the answer will have. For example, if we have 2.002 times 36.8. So if we plug this into our calculator, let me go ahead and pull one up here. If we put this in our calculators, we have 2.002 times 36.8. When we do this, we see the answer is 73.6736. So we have 73.6736. The question becomes how many of these digits are significant? So with multiplication division, what we want to do is figure out how many significant digits each of the individual numbers has. So 2.002 has 4 significant digits, while 36.8 has 3. So this means our answer has 3 significant digits. Whatever the smallest number is the number of significant digits your answer is going to have. So we want to round this to 3 significant digits. So it's going to be 73.7. This is the answer with the correct number of significant digits. Okay, let's try one last example that incorporates both addition, subtraction, and multiplication division. So if we have 46.8 plus 21.064 divided by 3.025. When we consider order of operation, we see that we first on the top here have an addition operation followed by the division operation. So first things first, we want to figure out what 46.8 plus 21.064 is. So we have, let's clear this, we have 46.8 plus 21.064. So this is 67.864. Okay? This answer is not quite correct yet for the addition because in this case I have only a single decimal place in this number, meaning this answer should only have a single decimal place. So for the addition part of this calculation, the answer is actually 67.9. Okay? And now we want to take this divided by 3.025. Okay? And if we put this into the calculator now, you can do it really one of two ways. if you start with this answer you originally had, the 67.864, and you take this divided by 3.025. So if you do everything in your calculator at one time, you end up with the answer 22.434. Okay, so let's put this one up here. So we have 22.434. If, however, you do the calculation in two separate steps, right? So we had the 67.9, which was the answer from the first addition calculation, divided by 3.025. In this case equals, so this is 22.446. So 22.446. So you can see how you can easily get either of these two answers. And the truth is that I would accept either of these answers. But right now, both of them are incorrect because we're not using the correct number of significant digits. So in this answer, we have 1, 2, 3 significant digits in 67.9 and 1, 2, 3, 4 in 3.025. So in both cases here, we need to round this to 3 significant digits. So in both cases, the answer is 22.4. One last thing that we should be conscious of, and that sometimes we deal with numbers that are called exact numbers, meaning they have an infinite amount of significant digits. So exact numbers, and these will always be implied in some way, like you'll be told they're a constant. So constants are exact numbers. These have an infinite amount of significant digits, an infinite amount of digits. And the reason this becomes important here is because if we are using an exact number in a calculation, that does not influence the number of significant digits. So for example, if I have 15, which I'm told is an exact number, times 2.04, the answer will have significant digits only influenced by 2.04, not by the number 15. So the answer of 15 times 2.04 is 30.6. And we're going to retain all 3 sig figs because 2.04 has 3 sig figs, and it doesn't matter that 15 only has 2 because it's an exact number. So 30.6 is the correct answer. If we had 15, again, an exact number, plus 2.04, we know the answer here is 17.04, and we're going to retain the same number of decimal places, 2 decimal places, as 2.04 because 15 does not influence the number of decimal places that carry through into our answer. So our answer actually ends up having 4 sig figs instead of 3 like we originally had.